Screen 1 sec. Hello, everyone, and welcome to the November 2nd meeting of the Identity Special Interest Group, Identity SIG here at sorry, got something stuck in my throat. Yes, welcome to the November 2nd Special Identity Interest Group for Identity. Today we'll be doing a quick working group status update, and then we have a couple presenters here from Polygon ID. Thank you, Otto and Alexander, for joining us here today. Just a reminder, we are under the Linux Foundation antitrust policy, so please be nice to each other and don't say anything that you don't want out in the public. Jumping into our working group updates, looks like the Hyperledger Indie Contributors Working Group met last week. Was anyone able to attend this session that might have a recap for us? All right. Looks like they were discussing some IAW takeaways and any 2.0 initiatives. Moving on, it looks like the Aries Working Group met yesterday. Was anyone able to attend this session? All right. They were discussing some.
Sorry, I did attend, but yeah, there's a lot of topics. Probably your recap covers it as well.
All right, sounds good. Thank you. And then yeah, if anyone has any questions, these all link to the latest meetings. So moving on, it looks like the Aries Bifold users group met on the 24th. Was anyone able to attend this session? All right, looks like they're also discussing some IAW takeaways and the next updates. Aries Cloud Agent Python met just a couple days ago as well. Was anyone able to attend this session?
Yeah, I was there. There's another first release of Occupy. Problem is I don't remember the version number off the top of the head, but you might just want to add the note. It's but unfortunately I can't remember what the number is.
All right, no worries.
Okay.
Thank you, Tim.
Look it up. Sorry about that.
Yeah, no worries at all. Moving on, it looks like they haven't met in a little while. Closure Ursa non-creds. Looks like TIOP had an all members meeting in October. Was anyone able to attend this TOIP session? All right, looks like they're looking at a few new task forces. And then the Technology Stack Working Group met just a few days ago as well. Was anyone able to attend this session? All right. Well, they have quite a few different task force next steps. So if you'd like to learn more, you can find out some links there. Moving on to the DIDCOM spec working group. I was unable to find too much on this in terms of updates. Sam, would you have anything for us?
We did meet. The discussion is about whether we advanced the DIDCOM2 spec to the IETF, which was the original plan. There was a little bit of a pause while the work matured a little bit in the creation of the users group, etc. And also some question about how that related to the trust over IP trust spanning protocol. The rough consensus is coming down on the side of advancing it to the IETF. Under the possibility that it wouldn't provide the TSP may not provide what we really need in terms of what's going on. So anyway, the short answer there is that advancing the spec to the IETF is likely.
All right, good to know. Thank you, Sam. And then for the DIDCOM users group, were they able to meet recently, or this is less relevant?
They didn't meet this last week because it was a fifth Monday, and they don't meet fifth Mondays.
Oh,
But
all right.
but still going on with some good discussion about stuff that's going on and all that.
All right. Sounds good. Thank you. Um, looks like the diff interoperability group has not met super recently. And that looks like a couple meetings ago. All right. Unless anyone else has any other updates they'd like to share, I think we'll move on to the presentation. Giving it a few minutes. All right. 1 second as I stop sharing my screen. And then today we have Otto and Alexander with a presentation for us. So take it away, you two.
Thank you so much. I appreciate the opportunity to present here. Shout out to Alfonso, who I met in Peru. You know, great to meet folks from Hyperledger in person. Also, shout out to Sam, also from the DITCOM group. Great to see it, and Keith as well. So yeah, my name is Otto Mora. I'm based in San Jose, Costa Rica, and I'm the Americas tech sales lead for Polygon ID. And I'm joined here by my colleague, Alexander, or as we like to call him, Sasha. So Sasha, maybe you want to introduce yourself?
Yeah, hi everyone. My name is Alexander Brezhnev. Yeah, I'm a technical leader at Polygon ID and responsible for the development of the protocol part of it.
Excellent. Yeah, so hopefully you can see my screen and we can get started with this presentation. So yes, also in the spirit of open sourceness and freedom, we are releasing this presentation under a Creative Commons license so that it can be leveraged for future use in any other setting. Okay. So yeah, so just a little bit of the agenda, looking into Polygon ID, verifiable presentations using ZK proofs, some overview of our DID method, how the CK proofs are generated, the credential issuance methods that are available, the discussion around identity management and other features of the DID method, also some details around how our Merkle trees operate and how we perform claims revocation. Then just a final look at what's available today, maybe some contrast also with other privacy methods, including BBS Plus and others. And then also some discussion of how the Polygon POS chain compares to Hyperledger Indy for the usage of blockchains and identity. Okay, so have you or a friend ever done this? So not quite a common thing, but I believe that you may have seen it. And what we think of this is people want selective disclosure in the physical world, right? They want to hide certain aspects of their identity documents. They want to keep certain aspects private. But with the internet being so widely available, and almost it seems like you can keep a secret nowadays, they maybe don't know that you can do this in the virtual world as well. Thanks to CK technology, this capability is now possible. And it is possible in a privacy preserving way, as we'll explain. So our DID method allows the ability to use ZK proofs, right? So you would have a verifiable credential. The verifiable credential would have information about you, your date of birth, your place of residence, maybe your credit score, a number of other things. Through the interaction with the third-party verifier, the third-party verifier can ask questions about it, and they would ask questions using a ZK query language that we've defined. And the questions can be in the form of, oh, are you over 18? Show me that you are a resident of Colorado, or show me that maybe you are not a resident of this list of sanctioned countries. Or it could even be a range question like, show me that your credit score is between 500 and 600. So these types of questions are asked by the verifier. The holder of the credential can then generate a ZK proof from his device, and his device could be either the phone or the browser extension identity wallet that he's using to be able to respond to this, right? This answer then comes in the form of a ZK snark proof that is generated, and then the third party can verify that that proof is correct, right? And so in answering that question, you've only revealed the correctness of the proof and the yes/no answer to the question that was being asked by the third party, right? And you didn't actually reveal the full credential, right? So quite similar to what you would do with other technologies that enable this as well, but we have our own way of doing it using set case narcs. So a common question that I get is, are Polygon ID set case proofs stored on chain? Because we do have other chain scalability technologies that store the proofs on chain, and the answer is no, right? We don't do that. We keep the user's data private. But can the Polygon ID set case proofs be verified on chain? And the answer to that is definitely yes. And as you will see, you have the option of either choosing that the proofs be validated off chain or that they be validated on chain, right? So you have the ability to choose either one. How does our did method look like at a high level, right? So our did method, as you can see, uses JSON LDs for the credential schemas. We have those credential schemas being generated. There is also a notion of the identity state of the issuer being recorded on chain before you can issue credentials. And there's a couple ways to do that as well. We'll get into the details of that. But essentially, once the holder has those JSON LD files in their device, they are then able to generate a verifiable presentation, which we've enveloped in a modified JSON Web Token, JWT or JWT, that is actually called the JW set for JSON Web Zero Knowledge that we've come up with. So this presentation packs these set case proofs that are the response to the queries being made by the third party, right? And then afterwards, the verifier can check the identity state, check the correctness of the proof, check that the proof has not been, the credential has not been revoked, and a number of other things, right? So the first method to issue credentials is what we call the SIG method, right? This method relies on the issuance of credentials with BJJ signature. At this point, the credential is then not added to the issuer's Merkle tree, but we just do a baby jub signature, which is then verified upon presentation. This is probably the method that uses the least amount of gas and is the most economical in terms of spending gas on chain. So after the initial issuer state has been published, which is just a few cents to get to do that, then it's just free to issue as many claims as you want. And this is very similar to the did ether method, which enables this capability as well, right? So you would see the user providing their information, the credential is then not added, but instead we just have a BJJ EDDSA signature added to the credential, and then you can just verify it, right? So as long as you're not revoking the credential or rotating keys as an issuer, you're essentially not needing to spend any gas for this. You can issue thousands of credentials without any need to spend gas. So this is the first credential method that we have. The second credential method that we have is what is called the MTP method or Merkle tree proof method. In this case, the validation of the proof is done against the hash that is published on chain, right? No personal information is ever shared or stored on chain, so we preserve the privacy. But interestingly, this method allows you to do some interesting things, such as having smart contracts being able to issue credentials, right? And this is a method that would require the spending of gas. In this case, we've estimated approximately 2 million gas on average, which is 0.36 Matic, which is still pretty minimal on the gas cost to do this, right? And also, if you wanted to do massive credentialing issuance, you could do batching so that you could optimize the cost of the gas issuance process, right? So that would be something that you can do as well. So this is the second method. Now, moving on to other features here, the did Polygon ID method also enables you to do identity management, right? So we do support the ability for you to rotate keys and have multiple keys, right? So an identifier controls a set of keys which for Web3, by the way, it's like trying to get away from that because people tend to think in Web3 in the blockchain world as an identifier, more of a public key, but we actually think of an identifier controlling a set of keys, right? So that's how we like to think about it. We do also provide civil resistance, proof of uniqueness through the usage of nullifiers. And then also a history of the profiles used, which I'll get to in a little bit, is used in their identity wallet. I would also like Sasha here to comment on our Genesis identity. Sasha, maybe you want to comment on the various ways in which the Genesis identity can be controlled?
Yeah, sure. So we have two ways of creating identity, basically. We have the ones that we initially started. It's a baby jab key controlled identity, where we add it into the claims tree, and then it's becomes an identity state, and part of this identity state hash is then becomes an identifier of the person. But also we later created another way of creating identities that is based on just Ethereum address. So it's Ethereum account controlled identity, where it could be externally owned account that is essentially a key pair of Ethereum, or it could be a smart contract or abstracted account. Yeah, but from functional perspective, they are almost identical. There are a few minor things that differentiate them, but yeah, and nothing too big.
Perfect. Yeah, so exactly, it just depends on the user preference of which way they want to see their identity. Excellent. So another interesting thing, and I believe this is the best way to explain it with this movie, I find there's probably the best metaphor, is the ability to manage profiles, right? So the default behavior that we have is that we generate an anonymous random identifier for each interaction that the credential holder will have with third parties, right? This is very much similar to what you would do with the incognito mode in Google Chrome or in Brave, where you're being protected against tracking and then you're generating random identifiers and skipping cookies and things of the like, right? If the user does want to be remembered by the third party, they can then decide to select a permanent identifier for interactions with that third party. So for instance, Hedwig could be your gaming profile where you are going online and using NFTs, collecting assets and digital collectibles, etc. But then maybe Patricia could be your more serious DeFi profile, right? And you can go on Compound and Aave and spend some stable coins and get some return. But interestingly, because of the usage of ZK proofs, any credential that is issued to Hedwig can be used by Patricia interchangeably, right? So you can use any credential and then show a specific identifier or expose a different identifier as you prefer, right? So this is a nice ability, I believe, for wallets and for people that just want to segment their digital life, right? They want to split out their identities. Sometimes you have a work profile, you have a kind of nonprofit that you volunteer at, and then you have your gaming profile. Then you want to keep those things separate, right? Also, another feature here is the ability to bridge your identity to other chains in the Ethereum ecosystem, right? So the identity state contract, which we will introduce in a little bit, can be bridged to other Ethereum 1, to the Ethereum L1 chain, as well as to other L2 chains in the Ethereum ecosystem. And this effectively enables Polygon ID verifiable credentials to work in other chains in the ecosystem, right? So this is currently done through our alliance with Radimo, which they allow this ability to do identity state bridging, right? And this is a nice ability which makes kind of your identity state portable across the Ethereum ecosystem. Another nice feature is the ZK query language that I was mentioning. So maybe Sasha, do you want to mention some features here, predicate proofs and so on?
Yeah, so it's query language that is inspired by MongoDB query language. So you can just write that I want a proof that you have a credential, let's say, of a KYC H credential schema type with a birthday that is more than some value. So in this way, you would prove that you are over 18. Or you can do a selective disclosure. You can ask, I want to see your passport number or name from this credential. So we have this query language, which is supports different operations like less than, greater than, equal, non-equal, in the list, not in the list, and also selective disclosure. Yeah.
Perfect. Yeah. So also on the proof verification, as I was mentioning, the proofs can be verified either on chain. You can feed the proof into a smart contract and take some ability, do an airdrop or do another action, or you can just verify the proof off chain and on your own just validate that the proof is correct and then take some action as a verifier. Another interesting thing, which I believe can be of interest to the group, is sort of the usage of this format that we came up with called the JSON Web Zero Knowledge. But I'll let Sasha maybe comment on this further.
Yeah, essentially it's a JWT token, where instead of a signature in regular format, that is a digital signature or a hash of data with a secret key, instead of that, we are doing signature using zero knowledge proof. Why we are using it is that because we have these identifiers and profile identifiers, and with zero knowledge we are proving that user is controlling this identity. So it's kind of signing this message that is inside with this proof that I'm controller of this identity that is saying something about myself.
Perfect. Thank you for that. Yeah. And also moving on to some additional features. I know this is something that Sam would like, of course, because we also love DIDCOM. We do have an adaptation of DIDCOM called IdentriCom. And as Sam would know, this communication is transport agnostic and would not require the usage of HTTPS like OpenID or OAuth does. So you could do, transfers over Bluetooth or NFC. Think of situations like a traffic stop or a place where you may not have that ability to connect over the internet and you just want to have a quick communication from device to device. So that's a nice feature. Some additional features, as we said, also smart contracts can verify credentials that were issued off-chain and on-chain. And then smart contracts can act as issuers of credentials using the MTP or Merkle tree proof method as well. So getting into the Merkle trees, right? So we do have a set of Merkle trees, and we're going to go explain each of them a little bit more detail. The initial one is the claims tree, and this claims tree is issued by the identity holder, and they will be able to add either keys or credentials issued to this Merkle tree. It is a sparse Merkle tree, and each credential that is added to this Merkle tree or key has what is called a unique revocation nonce. This revocation nonce can be used to revoke claims, and we will provide more detail to that later. But as you can see, the credentials issued can be either keys or actual credentials, and this allows you to add, more keys and so on. I think there's a question. Well, we'll take that question at the end. But yeah, great question actually, Tim. Okay, the identity state as well. So this notion of the identity state, right? So initially, identities are in what is called the genesis state, as Sasha was mentioning there. where their identity state can be proven directly with the identifier. But then the identity states are all published in what is called the GIST, or a global identity state tree, which is a sparse Merkle tree on chain. And then proofs can be provided to demonstrate that one of the identities is being used without revealing which one, right? So this is this feature here that we have. Then the smart contract that we have on chain is kept up to date with the information of the identity state. We'll also provide more details on that later. But the smart contract has a check of what is called a state transition function, which is required to update the identity state and verify the correctness of the transition. So you can create your identity, right? But in order to register that identity correctly and issue credentials that can be verified on-chain, you do need to have this initial state transition function done, right? So this does require to spend a little bit of gas, as I mentioned in the SIG method. But once you do that, you can issue, many credentials. And then as long as you're not revoking keys or revoking claims or adding new keys, etc., you won't be spending any gas. Okay, so then pulling it together, right? I believe maybe, Sasha, you want to comment on how there's an interplay between these three Merkle trees and the hashing that takes place.
Yeah, so from the very beginning, identity is created on a user's device in the wallet, where user generates his public and private key. And the first claim in this claims tree is actually a public key that belongs to this user. So from this, we just generate hashes of this Merkle trees. We hash them together, and it becomes an identity state of this identity, which becomes an identifier of this identity from the very beginning. And actually, we can prove just from this identifier that user has control over this key. User can prove that. So he doesn't have to be on chain published or somehow registered to be able to use this identity to prove something. And then over time, user can issue credentials to himself, to others, and also rotate keys or add revoke keys, which are essentially just a special type of credential that user has. And yeah, when user is revoking, what he is actually doing, he is adding revocation nonce that is inside the credential. He's adding it into the revocation tree. And he needs to publish his identity state at that moment so that it takes into force. So when others are checking that proof is correct and credential is not revoked, they are referring to issuer's identity state. They see and check that it's the one that is published on chain. Yeah. And third tree is a root of its root tree. It just has history of all their claim tree roots that we had. It allows us some interesting things to do in the future, like possibility to prove that credential was issued at some point in time in the past, but without revealing identity state when it happened. So it's another privacy feature of our protocol.
Okay, perfect. Yes, so moving on, we'd like to also contrast a little bit of the usage of zero knowledge proofs and identity. You can see some information here just to contrast The proof type is different, obviously, when you compare Polygon ID to AnonCreds, right? We're using G16 with Snarks. We do have the option to eventually migrate over to Starks, whereas AnonCreds use CL, and BBS Plus has its own signature scheme. Also, the keys that can be used, we have Baby Jub, and then more recently, we've also introduced compatibility with Ethereum controlled identities. AnonCreds uses this link secret for identity binding and the RSA for the CL RSA signatures, whereas BBS has this BLS scheme here. Selective disclosure can be done by all of them. Predicate proofs, well, as far as I know, currently only supported by Polygon ID and AnonCreds. The private non-revocation proofs we've implemented using sparse Merkle trees, which are computationally efficient. AnonCreds does it using the crypto accumulators, which are a bit heavier and more storage was required. Credential issuance, we've issued in the verifiable credential format against the identifier. It is not interactive. This can be generated either from a mobile device with our C libraries that are heavily optimized, or from a server. The AnonCreds uses a custom format against the link secret commitment, and it does require the interaction with the identity holder. Also, BBS Plus is issued in a VC format against the identifiers non-interactive. The off-chain verifiability for us, it is possible if you do cache the on-chain issuer state as well. So yeah, sorry, actually, on-chain verifiability, it is possible for us to feed the proof into a smart contract and take an action, because yeah, we can feed it into a Solidity smart contract. Okay. This part here, I don't want to come this across as like we're attacking Hyperledger Indy by any means. This is just a comparison of scalability. Again, Polygon ID, we've anchored it to the Polygon POS chain for this example, but it could be anchored to any other EVM chain. And also this is probably a little bit unfair, I would say, because I believe I heard that Hyperledger Indy might be moving onto a Besu network. But so just bear in mind that we are assuming the current state of Indy here. And so you can see some of the comparisons on the blockchain network, right? We said public interoperable network in Ethereum with L2 chains. In the case of Hyperledger Indy, it could be either permissioned or public on the sovereign network. We do have the ability to do interoperability with other EVM chains. As far as I know, that's currently not possible in Indy. The on-chain verifiability, we do have that ability, whereas Indy doesn't at the moment. There's a little bit greater decentralization on the Polygon POS chain, right? I do understand there's some limitations as well with the number of nodes that Indy can support. Smart contracts, we support them via Solidity. And credential issuance, I'd say pretty large still, right? Except maybe in our case, because of the SIG method, it potentially might be unlimited. The credential issuance cost, I think also there's not a huge difference. Maybe we're slightly cheaper. So yeah, so it just, I think there's, a little bit of a difference there, but not significant. The schema hosting is interesting though, however, because we do allow schemas to be hosted in IPFS or HTTP, whereas Hyperledger Indy would require that the schemas are hosted on chain. So yes, that's all I had. Maybe just looking at our ecosystem, right, and the elements that are available today. So for users, we have a Polygon ID app, which is a reference identity wallet to manage identity. You can generate claims, generate ZK proofs, but it's not the only wallet, right? We're not in the game of controlling people's identity wallet experience. So we actually have other wallets in the ecosystem, including AltMe, Verida, WalletID, and CLV. So they've integrated the Polygon ID SDKs. So yeah, the SDKs as well, you can have them in Flutter. They do have an Android and iOS native wrappers. The JavaScript SDK is also available if you wanted to use that instead of the Flutter to integrate. For issuers, we do have the issuer node, which is a server that you run in your infrastructure and enables you to issue credentials. You can host that yourself, or you can host that in Google or AWS, right? Actually, it's also available on the Google Cloud Marketplace. We also have SaaS providers, including Doc, Monarchy, and Kaleido that you can use to host that issuer node. They are currently providing that service. And then for verification of the presentations, you could use our off-chain libraries in Golang and JavaScript, or the on-chain templates that we provided in Solidity, right? So yes, you can take a look at our ecosystem, probably some familiar names here. You know, another nice one I would just take a moment here to highlight is Masca, which the plugin for MetaMask enables you to have Polygon ID working inside of MetaMask. So I think that's a nice feature. But yes, we also have other players, and you know, I'm not going to name them one by one, but we're happy to see this ecosystem grow, and we do have a marketplace of credentials that is coming up as well. So yes, that's all that I had. I'll leave the contact info here, and also our links to our tutorials that you can check on your own. And then I guess I'll jump into questions. Yeah, so just go ahead and take questions. First question, is there a link to this presentation? Yes, we will provide a public link to this presentation. I'll share that with the folks here after the call. Okay, I think there was yeah, go ahead.
So, I mean, I don't know much about Polygon. Like, it's the what's the chain is POS. Is this for, like, is there a production use case of this use of this right now, or is it more development, or where are you at in actual adoption?
Yes, we have 2 global banks and an Australian bank deploying production use cases. I can't name names yet, but it will be going live soon. And then we also have a couple of gaming use cases coming out next year. Currently, actually, you can get some gaming credentials, which is actually nice. You can port over some Steam ID credentials and then use that in a third-party community DAO to have a specific access to a Discord. So yeah, it's been growing. And yes, we do have some, I would say, Web3 and Web2 use cases. It's sort of a mix. Perhaps initially we would be more focused on the Web3 world, kind of providing solutions to DAOs and DeFi protocols, but we're also getting interest from the Web2 space as well.
Okay, great, thank you.
Okay. Yeah. Hey, Keith.
Yeah, thanks for the great presentation. Could you talk a little bit about performance? It's been a while, but the last time I tried the Polygon ID wallet, I mean, the demo wallet, it all worked great, but I did notice that, a lot of things took time. I mean, like a lot of zero knowledge architectures, like when the interactions themselves take time, as in like seconds, 5 seconds, 10 seconds. What does that look like today? Like what does the speed of transactions look like? Like, the verification or issuance or things like that.
Yeah. For the verification, the things that you noticed is actually it takes much more time to get schemas from the internet, check revocation status from the issuer or from on-chain, and so on, then generate zero knowledge proof. Like zero knowledge proof generation takes about 2 seconds right now to generate zero knowledge proof itself. The rest takes this getting revocation status, getting credential schema from IPFS or from HTTPS that could be pretty slow in case of IPFS. and we are currently working on caching these schemas so that we do it much faster with caching. So yeah, performance will be improved a lot.
Thank you.
Yeah, regarding issuance, there is no like hard limitations on scalability. Like you can scale it very much. The thing that you need to do it's just DDSA signature and Poseidon hashes that you need to do. So you can put a lot of machines and do it in parallel, no problem. So there is no limit on how many. It's just a performance of a single machine. So you can scale it.
Yeah, we're getting better. We've optimized our C libraries even more. I think it'll get better over time.
I've got a
Yeah,
question. The on-chain issuance and verification requires the attributes themselves to pass through a smart contract, correct?
No, for the verification part, so what we are doing is we are actually raw credential is stored on user's device. Then we split all the fields of these JSON-LD documents into key pairs. They are added into the Merkle tree. And when user wants to prove something based on this credential to the verifier asks a specific question. I want to know that user's birthday is less than 2000, let's say, yeah, year and so on. And then a user just has this input in form of ZK query and generates proof on his device and sends this to the verifier, this proof. And he's not sending credential or he's not sending any other data other than this zero knowledge proof with a reference to the issuer's identity state.
Right, but for on-chain verification, that requires the verifier to use the chain to verify that, correct?
Yes. It's
right. So if it's not a predicate 16, proof, so if it's not a predicate proof and I'm actually want to reveal an attribute, then the attribute that I'm revealing does travel to the smart contract for verification.
Yeah, if you are doing selective disclosures, then obviously yes.
Right. Okay. And same thing for issuance. Obviously, it can't issue the credential without the attributes in play. So on issuance, you would also have to pass the.
You mean for on-chain issuance?
For on-chain issuance, you would have to pass the attributes to the smart contract on-chain.
Yeah. Okay. So for the on-chain issuance, we have actually two major ways of doing it. One is when you're collecting data from the data that is actually on chain. Let's say it's your Ethereum balance or some token balance, or that you own NFT, or you have a trade volume of some amount on Uniswap or whatever. And then you as a user, you are just calling this smart contract that fetches this data, embeds it into data structure that we call core claim, and then adds it into the Merkle tree of this identity on-chain identity issuer. And then user is able to use it to prove something in private to other smart contracts or to off-chain verifiers. But he can do that from another, let's say, Ethereum address, and in this way he can break this link between, I own this amount of money, let's say on one Ethereum account, but I don't want to reveal it and link my identity and another Ethereum address to the one that has this amount of money, and then I can use it, and with just zero knowledge proof I can prove that I have this amount more, or like whatever requirements are on the verifier side. And another way of issuing is actually with zero knowledge proofs. So smart contract can actually verify that user have generated credential to himself in a correct way based on data that is verifiable somehow. And this could be, for example, a user can have a digital document that is digitally signed by government. For example, he can have a biometric passport. Yeah, then he may fetch this data from biometric passport, generate zero knowledge proof that he has it. He has that it's digitally signed by valid key of the government, and then that he transformed and put fields from this data blob that was signed into correct places in the our binary claim structure, and just provides this zero knowledge proof to the contract. So this on-chain issuer would then just verify that zero knowledge proof is correct, and that hash of the claim is this one. So it's not revealing any data to the on-chain issuer in this way, just the credential hash. But it has a lot of fields that, let's say, user can have one field with random numbers just to prevent brute forcing. So that then this hash is together with zero knowledge proof is sent to smart contract. It does verification that the process was done correctly, and yeah, then it is issued in this way without revealing any data actual to the smart contract that performs issuance.
Thanks.
All right, perfect. There's a question there in the chat. Are there any governments that provide electronic passports, Estonia or mobile drivers? I mean, I think there's a couple of efforts going on to provide mobile driver's license in the state of California and a couple of others in the US. Yeah, I think there's some. I don't know about the electronic passports, but maybe Sacha, do you know about electronic passports by government?
Yeah, like biometric passports are pretty common in the world. So you can just read it with NFC in your phone, and we've done that before. So it's pretty easy to get this data from biometric passport or ID card, and in many countries they are available. So yeah.
Okay, perfect. Keith?
Yeah, so I guess my question is, so I think like a lot of this technology is really interesting, specifically for a lot of the on-chain interactions. But I think my question would be, it still kind of strikes me as like I forget my language, but like a proprietary ident3 technology stack. And I guess the question is like, how do you guys view standards or standardization? Like, do you see like components of this moving through a standardization track, whether it's, pick your standards body, that doesn't matter so much, but like, how do you see your technologies like progressing, moving forward?
Yeah, first of all our libraries, everything is open source, so you can just use it. And there is a few other projects that have actually built their identity systems on top of ident3 protocol, and so it's not a problem. The other thing is that, yeah, you mentioned standards, and of course this zero knowledge proofs, way of presenting these proofs and querying them and signing credentials and so on. It's not a standards, but we aim to eventually standardize them. This is the idea.
And just, I mean, do you have any ideas right now where you would potentially standardize them? Because you know, it's a complex question, but I just wondered if you had any early thoughts.
Yeah, through W3C, diff, and so on.
Yeah, I think like the JWP might be, for instance, a logical, right? We created the JWZ, but that was before the JWP came over, the proposal for Microsoft for that. I think we are very much still aligned with DIDCOM, right? So our proprietary Identicom flavor, we could integrate that into the larger DIDCOM spec. So yeah, I mean, there could be some engagements. Like actually, we have a meeting coming up with the DIDCOM group later this month to present them the Identicom format protocol that we've created. So yeah, we're open to these sorts of things. Also, we're becoming more cross-chain, where we used to be heavily Polygon chain biased. So we're also working towards that. Yes. There's a comment here from Bipin. Electronic passport sign exists. MDL is still being born, eventually integrating with KYC. Oh, yes, I remember you had a question around other KYC or issuance providers. I just wanted to provide a quick flavor on that before we wrap up here. So you can see here some of the providers of credentials in our ecosystem. Yes, some familiar names perhaps. Some provide proof of personhood, liveness. Some provide free proof of personhood, such as the case of Synapse. Civic, actually almost near free proof of personhood. Reputation credentials, credit scoring, right? Various use cases. So yeah, some folks there in the ecosystem. We do have a larger selection that you can see in our ecosystem page. Yeah, but just wanted to give some flavor of that. All right. Well, seeing as there's no additional questions, I just wanted to thank everybody here for the invitation, and also Daniela, who told me that she would see this recording later. And just reiterate that, yes, we very much like industry engagement. We do value open source. That's more of a personal statement. I love Linux. I love open source. I know Sasha loves Linux too. So we're all about you know, contributing this to the rest of the world, and hopefully we can start engaging more actively in that space.
Awesome. Yes. Excellent presentation. Thank you both. If you could just make sure that you either send me or Shar that link to the public presentation, we'll make sure to put that on the page here. So, but yes, that brings us to the end of the meeting. The recording's on YouTube. I think the link was sent out in the chat earlier. But we'll go ahead and post the link one more time just in case anyone wants to see it. And thank you all for coming. We'll see you in a couple weeks.
Thank you.
Thank you. Thank you. Bye-bye.